Tim and Neha, where are you coming to us from today?
I'd say
I
I'm in a
am
pretty good place
in,
these days, growing a lot. And did you mean geographically? I'm sorry,
I
Neha.
think so.
However
Maybe you
you
should
want
answer
to take
question.
it.
Okay, so geographically, I'm coming from California, Bay Area.
Nice.
Denver, the southwest part of Metro Denver, um, where it was not as cold today as it has been. This is a pretty cold time of year for us, but it's kind of okay.
It's nice and warm where I am.
Yeah, we know. Although it's not always warm there this time of year. I mean, I was there a
True.
year ago, and there was a few. I felt like I needed a jacket.
Yeah.
Which is saying something.
Never know. San Francisco area. Awesome. Folks are rolling in here. We want to be respectful of everyone's time, so we will start in just a moment. Lots of good turnout, lots of interest in learning about Pinot. Great. Welcome to Have a Glass of Pinot. I'm sure people make Pinot jokes all the time, right?
I doubt that has ever happened before. And hang on a second. Speaking of jokes, be right back.
Uh-oh.
I'll just hold this up. Hopefully you can see this. My current status is caffeine is still in the game. In a little while, I'll ask caffeine to get on the bench and ask alcohol to suit up. And that may even involve Pinot. I'm not sure.
Were those cards of some sort?
They're little coasters.
Coasters.
Yeah, they're just I just haven't taken them out yet.
Nice. Yeah. Nice. All right. Well, what do you say? Let's get the show on the road here. Someone's asking if gotcha. Right. The contracts. Always fun having chat windows going too, because you read things sometimes out of order and you're missing part of the conversation. Like, oh, someone's in a freezer. What was that?
Do they need to be let out? Are you okay?
Awesome. Well, thank you everyone for joining us. We are hosting the virtual edition of the Data Science DC meetup for January here. If this is your first time, welcome. If this is your second time, you're also welcome. Anytime, really. You're still welcome. So thank you for coming to learn about Kafka and Pinot for real-time user-facing analytics. We have both Tim Berglund and Neha Pawar with us, and they are going to be, along with a couple members of the Pinot team who are, I think, watching and in the chat perhaps. If you have questions, they'll be able to answer some of those as you go too. So we got a whole suite of folks here with us and lots of exciting stuff to learn. A couple of housekeeping items first. Data Science DC is part of Data Community DC. That's the nonprofit organization that is the umbrella group for all of us. And I know we have Tommy Jones, who's also a Data Science DC co-organizer here, who's on the board, and Will Angel, I see. And apologies if there's other folks who are missing, but it's a good organization for data science meetups in the DC area, whether they be in person or virtual. So we have a lot of groups that fall under our umbrella. If you're interested in finding out more, go to datacommunitydc.org. Put that in chat here at some point. And you can find out what else is going on. Always stuff going on. So for Data Science DC, Maria, Tommy, and I are the folks who bring you these meetups. And you can reach out to us if you have questions or want to find out more information. We do have a code of conduct. It looks like probably most other code of conducts you've seen. Short edition is be nice to each other. And if someone you think is not being nice or not treating you respectfully or sees some other harassment or unwanted behavior taking place, reach out to myself or Tommy right here, and we'll get to have the fun job of dealing with it. We want this to be a welcome environment for everyone. We have a diversity statement. We like to have a diverse community. We want to have a diverse group of speakers. So if you have folks who if you're interested in speaking, or if you know folks who are interested in speaking, at a data science DC meetup, please do shoot Tommy or myself an email. And we want to make sure we are representative of our community. I gotta say thank you to a couple of the Data Community DC sponsors who help make things happen. They would be bringing you pizza if we were in person, probably, soft drinks too. But we're remote here, so yeah, instead they're paying Zoom subscriptions. So thanks to these folks who help make this a reality. Anybody have community announcements at this point? Any other meetups coming up? I do want to mention a Pinot meetup that's happening next week. I'll shoot that out here. We'll be back next week. There it is in the chat. If I say Slack, I mean chat. In the chat, there's a link to next week's meetup that'll be taking place for folks who are maybe totally brand new and want to find out more. That's a great place to go. Anybody else in the community got meetups they want to share? Put them in the chat right now. It looks like George says that there's a cool data science event that a partner meetup Deep Learning Adventures is hosting next week. Check that one out. It sounds exciting. Deep Learning and Adventures. Awesome. Cool. Thanks, George. Other folks got anything? Caden says we have a meetup Tuesday. Tim is presenting. Tim gets around in his presentations here. This is great. For Walmart Labs DC Metro meetup. Cool.
You're right, I am. Thank you.
Awesome. That sounds cool. I didn't even know there was a Walmart Labs DC Metro meetup. I'm gonna have to go check that one out. Other events, put them here in the chat or hold your peace. All right. Thank you everyone. Any other community announcements? Anyone looking for jobs or hiring? Let folks know in the chat window. And we like to have folks, kind of huddle in real time when it's real time, real life, and when it's Zoom, you can put something there if you want to have a way you want someone to contact you, either if you're looking for volunteer opportunities or looking for a job, or you have jobs, internships, mentorship, whatever it is you're looking for or what you have to offer. If you have something you want to share, please put it in the chat. Oh, Will's got one more. DataViz DC, great active meetup. They have the next monthly meetup February 11th. Cool. I suggest joining DataViz DC if you're interested in data visualization. And that's, I think, all right. One last thought. Data Science DC, we don't have another meetup in the works right now. We don't have something scheduled yet, but we have a couple things in the works. So do subscribe to our meetup group to make sure you find out when those things are happening. All right. Cool. One other nice announcement here from the Apache Pinot folks. They're working on something to help make it easier for devs to deploy Pinot. So if you're interested in learning about that, hopefully I don't mispronounce it, but Uday, on Pinot Slack or right here in the Zoom chat, or you can email him if that's something you're interested in. Okay, there's a couple folks hiring. Great, I won't read it all up loud here, but Excel is hiring. There's some visiting scholars. Great. Cool. We're gonna have a talk. If you have questions, post them in the chat as you go. We might have folks answering them who are part of the Pinot team again. If you showed up a few minutes late, you might not have heard that, but that's an option we'll have. And then we can also ask our panelists throughout the talk, or maybe at the end if they aren't addressed. Neha, Tim, anything else I should say, or you two want to just take it away?
I think we're ready.
All right, I'll let you introduce yourselves and take it from here. I'm gonna stop sharing my screen right now.
I think Neha is going to share first. There she is.
Yes. All right. Thanks everyone for joining. Welcome to our talk. Tim and I are very excited to be presenting to you using Apache Kafka and Apache Pinot for user-facing real-time analytics. So before we get started, here's a little bit about us. Tim, do you want to go first?
Sure. My name is Tim. I look vaguely like that, and I run the developer advocacy team here at Confluent. Confluent is a company that makes an event streaming platform and hosted fully managed service based on Apache Kafka.
And I am Neha Pawar. Currently, I am an engineer in a stealth startup. I'm also a committer and PMC on the Apache Pinot project. All right, let's get started. Oops. Okay, so the first question on everyone's mind must be, what is user-facing real-time analytics? So I like to call user-facing real-time analytics as analytics for the all and analytics of the now. So there's two aspects here, right? One is user-facing and the other is real-time. So user-facing or site-facing analytics is the analytical tools and applications that you would expose directly to the end users of your company. Gone are the days when analytics was just a thing for execs and PMs and analysts in boardrooms. The end users of your application also want analytics, and you can build a far more impactful and engaging product experience if you expose analytics to all of your end users. The other aspect here is real-time analytics. And to understand that better, let's take a look at this graph that shows the relationship between time and the value of data. Yesterday might be a long time ago for some businesses. Insights are the most valuable to them if they are delivered instantly or as close to instant as they can possibly be. One of the best examples of user-facing real-time analytics is the Who Viewed My Profile application on linkedin.com. So here you can see your profile views as fresh as a few seconds ago, and you can slice and dice them by dimensions such as job title and company and so on. Now, to load a dashboard like this, every time a LinkedIn member looks at another member's profile, you would have to capture all that data. And every time a LinkedIn member comes to their Who Viewed My Profile application tab, all this data that is being captured in real time needs to be queried and served also in real time. And for a company of the scale of LinkedIn, this will easily translate to several thousands of events per second and several thousands of queries per second. Another great example of user-facing real-time analytics is Uber Eats Restaurant Manager. So Uber built Uber Eats Restaurant Manager to provide instant analytical insights to restaurant owners on Uber Eats into their orders data. Here you can see sales metrics, missed orders, inaccurate orders, top selling items, menu item feedback, all in a very real-time fashion. Now, as you can imagine, to load a dashboard like this, you would have to run several complex analytical queries. They would all be running concurrently. Multiply that by all the restaurant owners across the globe, and that's going to be a large amount of queries per second for the underlying database. And in both these examples, the data that the application is serving needs to be super fresh, sometimes as fresh as seconds ago. And the queries need to execute with latencies in the order of milliseconds so that the end users get a fresh and interactive user experience. All right, so as we saw just now, user-facing real-time analytics comes with a very unique set of challenges. The data that the system serves needs to be as fresh as possible. So our system needs to be able to ingest data in real time and also serve that data queries instantly, also in real time. The data coming into such systems tends to be highly dimensional and comes in at a very high velocity. And the results are often expected with latencies in the order of milliseconds, even in extremely high throughput. Plus, as a system, you would want it to be highly available, scalable, reliable, and have a low cost to serve. Now, this seems like a very complex problem. And so how should we go about solving this?
Well, I don't know.
I'm going to call my good friend Tim. He works with a lot of events and real-time data. Maybe he has a solution for us. Hey, Tim.
Let's see if I can do it. I'm going to, actually, I'm going to try sharing my screen. This will stop you from sharing your screen. And there we go. So let's take a look at what we might do here. So, Neha, thank you for explaining all of that. You've got Real-time analytics and that fundamentally event-driven world is one of the primary motivators. Because again, in what I do in my day-to-day, I think about Kafka and event streaming. That's one of the primary motivators for people going to event streaming. Interestingly, there's another motivator, which is just the integration of components in a system, whether those are mainframes talking to applications or microservices talking to one another. So even if you come into Kafka not thinking about real-time analytics, if you come into it from an application modernization, microservices integration perspective, you usually end up meeting the analytics people around the back. So one way or another, you're going to have all this event data lying around, and you're going to want to understand it, and you're going to realize that understanding it, like Neha said, with second or millisecond latency is desirable. So let's talk about kind of how Kafka works. If you've got a world filled with events, you need a place to put them, and Kafka puts them in a thing called a topic. And if you've ever used any sort of messaging system before, you've probably heard that, that term. Interestingly, Kafka is really not best thought of as a messaging system. A topic is a log. So those let's back up. Those events that get written into that topic, they stay there. So Kafka is a durable place that can function as a system of record where the events of the business are collected and stored. That's really important. So if you're new to Kafka, don't let that statement just go by unremarked. Kafka is a log. It's not a queue. It's a big, giant distributed log. And that has architectural implications that are difficult to overstate. All right. But it would be no fun at all if it was just one log. I mean, how you think about that, how's that implemented? That's a file somewhere, right? If it's durable, then these are going to be written to a file system. That implies it's in some kind of storage, and there is some sort of computer that babysits it, and you wouldn't want there to be just one of them. So this is going to be important later. Kafka has a partitioning system. So you can take that log and you can break it up into pieces, and those pieces can reside on different machines in the Kafka cluster, different brokers. And as you produce events to that topic, the producer will have some means of distributing those events among those different partitions. And I'm showing 3 here. There could be 5, there could be 10, there could be 100. There could be a lot of partitions. Each partition can be managed by a single broker. So you have the possibility of scaling out topics to really large sizes. If you've got large throughputs, very high velocity messages, if you've got long retention periods, if you want to remember messages for a long time, you might need to scale that out a lot. So that's a thing. You can partition topics. That there are some interesting things arise there. Like you might want to know something about the order of messages, right? In what order did they arrive? And once we start doing this partitioning thing, you kind of leave the world of strict global ordering. If you're going to scale out, you're not going to retain the absolute ordering of all of the messages, all of the events you've ever stored. So what Kafka does is each message is not just a sequence of bytes, but it's got a little bit of structure. It's a key and a value. And so by default, what happens is when you're writing a message to a topic, you take a look at the key, and the keys are represented by those shapes here, right? So you see the solid square, all of those get assigned to partition 0. They get hashed. You run the key through a hash function, and the output of that hash function tells you to which partition you're going to produce the event. So if you just look at the picture here, you see the solid circles 4 and 5. Those are both on partition 1. There's a single solid diamond that's on partition 2. The open squares 8 and 9, those both go to partition 2. So the same key, messages of the same key, always land in the same partition. That's really, really important. That's important for application design, right? That's kind of the Kafka data modeling concern, is what am I going to use for my key? And as Neha is going to talk about later, that interacts with the way Pinot works in some interesting ways to optimize the performance of queries. So the fact that Kafka partitions is important for its ability to scale and interacts with the Pinot integration. how do we get stuff in? Well, there's an application called a producer, and that is an application, right? That's code that you write that's external to the Kafka cluster. You use a library that's provided by Kafka or provided by the community elsewhere, that to speak the network protocol and do all of the babysitting of connections and waiting for acknowledgments and retrying and all that stuff that is fun to write once when you don't have anything else to do. But if you have problems to solve, you don't want to write that producer code. So you use a library that does that, and the rest of the functionality in the producer is your code, getting events from somewhere in the business and producing them to a topic. Reading, and so under the covers in the producer library, there's actually really cool layers of complexity that are 100% not in scope for tonight. I don't want to trivialize the idea of the producer, right? It's some interesting code, but conceptually, it's pretty simple. You put things into topics. It's the one who decides what partition you write to. You get the point. Reading is a little more complicated than that. So let's just talk here for a moment. You see here, there's going to be some animation, but you can have more than one consumer on a topic. And this is so important. Consuming doesn't actually consume. It doesn't destroy anything. It just reads. So I can have consumer A read through all the messages and all the partitions, and I can have consumer B do the same thing. They maintain independent offsets. They're not correlated with one another at all. So if I have a topic that has interesting data in it, I can have lots of readers doing that reading. Also, they scale out. So if you notice in the still picture before the animation starts, consumer B is just one instance. It's reading all the partitions. Consumer A is two instances. It's the same application, just deployed to two containers or two cloud servers, whatever you've got there. And the cluster tries to assign partitions to those instances as fairly as possible. And that happens dynamically, right? You run these things, and then as you add instances, that reassignment happens in real time. So you got the ability to have a fairly robust set of readers on that data stored in that distributed log. Life gets interesting, though. So, what do you do when you read? Well, the operational use case, the non-analytics version of reading, is that consumer is a microservice, and the data in the topic is, say it's orders in Uber Eats. Well, who cares about orders? I don't know. Probably all kinds of services. There's probably a fraud detection service. There's probably a customer loyalty service. There's probably 10 services that are involved in talking to the restaurant and talking to the hungry person. It's kind of dinner time here in Denver. This Uber Eats use case is actually a little bit of a challenge for me right now. But imagine those services. They are not concerned with analytics. They are concerned with consuming the event, doing some kind of computation, and producing a new event somewhere else. So that saga can unfold as those services participate mutually in the choreography of the system. That's one thing those services could be doing. The other thing those services could be doing is analytics, right? And we're going to get back to Pinot in a minute. Neha's going to talk about what Pinot does. Kafka has analytics capability. The Kafka ecosystem has some analytic capability also. And one of my favorite ways to get that done is a thing called ksqlDB. So ksqlDB is just what it sounds like. It's a streaming SQL. So you can actually write queries that consume events from a source topic. You write the query in SQL, and it'll consume events from a source topic. You could do aggregations. You could do grouping. It's getting to be a fairly interesting language, and those queries run on a cluster of ksql servers, produce their results to an output topic. You can create tables in ksql that are queryable over a REST interface. So kind of for like the stuff right? If you know you've got an operationalized query and you want that to run on the events in your Kafka cluster, you very much know what the inputs are, what the outputs are, what the analysis is you're doing in the middle, what the needs of the application are. ksqlDB is really good for that. It's low latency, it's high throughput, but you got to know there's nothing ad hoc about it, right? You're not going to explore data or just kind of discover things with ksqlDB. But by the way, it looks like this. This is kind of a group and a join and an aggregate query in ksql. Super cool thing, but and incredibly useful. I don't want to say but too quickly, but I will say but. It doesn't do everything. And so if you're thinking about this, like Neha was talking about before I got started, there are kinds of queries that you're going to need some other kind of system on the back end to be consuming, acting as a consumer, reading messages from topics and populating itself as an analytics database to be able to answer questions, different kinds of questions than what ksql is going to do. So these kinds of things, milliseconds of latency, thousands of queries per second, I'm going to hand back. No, I'm not going to hand back. Sorry, missed my transition. If you imagine this kind of ecosystem, and you've got, higher latency things like Spark SQL. Okay, Spark SQL is incredibly flexible. It's SQL. You can do it on repositories of static data, kind of archived data in S3 or whatever. Presto BigQuery is certainly a popular option. I mean, in the Kafka world, we have a sync connector that'll output your data to BigQuery, so you can write BigQuery queries. Extremely flexible, also higher latency. In the middle, Druid, Elasticsearch, a little less flexible, certainly lower latency for those two. And then you have your basic key value store, which is incredibly low latency, right? But yeah, I mean, and also, to be fair, it's really flexible. You can do anything you want. It's just like you have to write all those queries in assembly language, which if you have a job and people expect output from you, you don't want to do. Cool science fair project, but I don't think you want to make a living at that. So, Neha, I'm going to hand back over to you.
Okay, sorry about that sloppy transition. But Tim, I think Pinot is the exact thing that we're looking for to solve the user-facing real-time analytics case that we were talking about. So I'm going to tell you a little bit more about Pinot. Thanks for the great introduction on Apache Kafka. Pinot is a distributed OLAP data store that can provide ultra-low latency, even in extremely high throughput. Pinot can ingest from batch data sources such as Hadoop, Azure, S3, and more importantly, from the context of the problem we are trying to solve, it can ingest directly from streaming sources such as Kafka and make that data queryable instantly. At the heart of the system is a columnar data store with several smart and powerful indexing techniques and pre-aggregation techniques for low latency. This makes Pinot a great fit for user-facing real-time analytics and also for other applications such as anomaly detection, dashboarding, and even ad hoc data exploration. Pinot was originally built by engineers at LinkedIn and Uber, and today it's a very mature product that is used by several big data companies across the globe for user-facing real-time analytics. The open source community is growing rapidly. And to give you a sense of the scale at which Pinot can operate, some of the largest Pinot installations have been known to ingest events from Kafka at ingestion rates over 1 million events per second, while serving queries at over hundreds of thousands of queries per second, while maintaining strict latency SLAs in the order of just milliseconds. So let's add Pinot to our solution, and I think we have a winner. So how is Kafka and Pinot working together under the hood? How are they exactly interacting with each other to go from events to analytics? To understand that, let's take a high-level look at Pinot's architecture. Let's say we have a Kafka topic that we want to ingest from. The first component that I'd like to introduce in the Pinot cluster is the Pinot servers. The Pinot servers are directly consuming from the Kafka topic. They are also indexing the data as they ingest it, and they serve the queries of the data that they have. Then we have the Pinot brokers. The brokers are accepting queries from clients. They forward those queries to the Pinot servers. They get the results back from the servers, merge them, and send them back to the client. Then we have the Pinot controller. The Pinot controller manages all the components of the Pinot cluster with the help of Apache Helix for cluster management and Zookeeper as a metadata store. Now let's double click into this a little bit more and see the exact interactions that take place between Kafka and Pinot. So let's say our Kafka topic has 4 partitions. To bring this data into Pinot, we would be creating a Pinot table. And once that is done, the Pinot controller is going to look at the available servers that we have and the number of partitions in the Kafka topic, and it will come up with a mapping from partition to Pinot server. And now based on this mapping, the Pinot servers will get notified to create Kafka consumers to consume events from the partitions that have been assigned to them. So as you can see, server 1 has created 2 Kafka consumers to ingest from the pink and yellow partitions, whereas server 2 and 3 have created 1 Kafka consumer each to consume from the green and the blue partition. Now, as these servers are ingesting the data, they are also indexing it. This data is kept in memory, and this in-memory data is instantly available to serve queries. And then periodically, the in-memory data gets converted to a Pinot segment. A Pinot segment is just a part of the data that is packed with the indexes and the dictionary encodings and stuff. So this Pinot segment will get flushed onto the server's disk and also get persisted to a deep store. And then the consumption will continue from where it left off. And the same thing keeps happening again and again for each and every partition on every server. The Pinot controller is the one that acts as the single coordinator for all these actions that are happening. And all actions are determined solely by the mapping that the Pinot controller creates and maintains. So because of this design, it is very easy in Pinot to handle changes such as increase or decrease in the number of Pinot servers or increase in the number of Kafka partitions and so on. Great, so far we learned about Apache Kafka, we learned about Apache Pinot, we saw how they both work together. You can pretty much solve any user-facing real-time analytics use case using this combination. All you have to do is point your Pinot to Kafka and start querying. And we're now going to see a demo to understand just how easy it is to go from events in Kafka to analytics in Pinot. Great, so in this demo, I am going to start a Pinot cluster. Then I'll be starting a Kafka cluster. We'll then push some events to a topic in the Kafka cluster. And after that, we'll create a table in the Pinot cluster, which will ingest from that topic. And then we'll see how we query all that data. So I've already downloaded the latest release for Apache Pinot as well as for Kafka. And as you can see here, I have started the Pinot server using a quick start command that is available in the Pinot tools. So this command is bringing up a Pinot controller, it's bringing up a Pinot broker, and 1 Pinot server. And while this starts up, let's go take a look at, let's go start a Kafka cluster. So again, I am starting a Kafka cluster using a quick start command in the Kafka tools. And while this comes up, let's take a look at the data that we want to push. So I have some data for ad clicks. And that data looks like this. In each record, we have the dimension country, we have browser, we have device, and then we have the actual ad clicks metric, and we have a timestamp. Now, in a real production application setting, you would use the Kafka producer, as Tim told us about it earlier. You would use a Kafka producer in your application to capture these events as they are happening and publish them as they are happening. But for the purpose of our demo, we are going to do a one-time bulk load of these events into a Kafka topic from this file. So let's go ahead and do that. So here I am using the Kafka console producer command, to which I'm going to give the details of the Kafka broker. And here's a topic name to which I want to push these events. So this command is going to create that topic and start pushing these events into that topic. And these events are now into our topic. Let's check if our Pinot cluster is up. So yes, the Pinot cluster is also up. So now we can come to the Pinot cluster manager, which is on the Pinot controller, hosted on the Pinot controller. This is where you'll see like a complete summary of all your Pinot components. And you can also do operations like creating a table. So before we create a table to start consuming from that Kafka topic, I'm going to add a schema. Right, so I'm going to create a schema for the click events data that we want to ingest. So in the Pinot schema, this is your chance to define how your data looks like, what are your dimensions going to be, what are your metrics going to be, and so on. So according to the data that we have ingested, I want to have a country column. And let's say I want to have a browser column. And I also want to have a clicks for the metric that we're trying to collect. And let's also include our timestamp column. Let's save the schema. And now we can add a real-time table for click events. And let's define the topic that we want to ingest from and the details of the Kafka broker. And our table is ready. We also have a segment here that has started consuming. So we can come to the query console and we have our data all ready to be serving queries. Now, you may not always have a flat payload like this. It's possible that you have something a little bit more complex. For example, your payload could be something like this, where you have a person, which is a nested field with name and address. With an address, you have street and line numbers. Even then, you don't need to do any pre-processing. Kafka and Pinot are perfectly equipped to handle this ingestion for you. So let's see how to do that. From the Kafka side, we pretty much don't need to do anything different. I'm just going to run the Kafka console producer command again with a new topic, person complex. And the complex JSON object that we saw in our payload, when we store it in Pinot, it's going to get stored as a JSON string. So let's see how we can do that. Let's go back to our cluster manager and add a schema for our new table, person complex. And to store the payload as a string, I'm going to use this column called person string. Let's also include our timestamp column. Let's save the schema. And now when we create the real-time table for person complex, this time we are going to add some transform functions to our person string. The transform function that I will add is JSON format. So this is telling Pinot that take the nested JSON field person, convert it to a JSON string and store it as person string. And again, the Kafka topic. And the Kafka broker details and save. Let's go check out our person complex table. We have a segment that is consuming. And as you can see here, our complex JSON payload got stored into Pinot as a string. So what if you wanted to extract something very specific from this payload? You can do that using UDFs. So in this particular case, I'm going to use a UDF called JSON extract scalar, where I'll say from person string extract using this JSON path. And with that, we can extract exactly what we want from the complex JSON. Now, you must be thinking that what if you don't want to pay the overhead of running this complex UDF every time with each and every query of yours, and you would rather prefer to upfront extract everything. So even that is possible without you having to do any pre-processing. Pinot can help you extract everything upfront using more ingestion time transform UDFs. So let's see how we would do that. Let's add a schema once more for a table called person flat and say we want to extract name and we want to extract address of the person, and we also want to have our timestamp. And this time when we add a real-time table for person flat, we are going to add transform functions again. So for name, I can add a transform function which is telling Pinot that from person, just give me the name using this JSON path. And for address line 1, from person extract address street line 1, and we're going to use the same person complex Kafka topic from before. Let's go check out our person flat table with the segment, and everything has been pre-flattened for us now. So this is what we saw so far. We saw that we can ingest simple fields or nested fields, and we can use UDFs during query time, or you can use those UDFs during ingestion time to transform your data to exactly what you want it to be. Along with JSON extraction functions, there is a bunch of other UDFs you can use, like datetime transforms, array, string, and math functions. You can also write your entire Groovy scripts inside the UDFs for the more complicated logics. And the whole UDF design is very pluggable, so it's very easy for you to write your own Java class and put it into your Pinot cluster. Pinot has a bunch of powerful indexes that can really help you when you want to bring your latencies down. For example, we have the classic sorted and inverted indexes, and then some advanced ones like range and geospatial and text index. One very special index that I'd like to talk about briefly is the star tree index. Star tree index lets you maintain pre-aggregated values for certain dimension combinations, and it also lets you decide exactly which dimension combinations to pre-aggregate and how many values to pre-aggregate. For example, if you had your ad clicks data like before, and you decided you only want to pre-aggregate country and browser. So this is how your star tree would look. On the first level, we have pre-aggregations for country, and then within each country, we have pre-aggregations for browser. And now when you get a query like this with a filter on country and browser, this is going to be a single lookup. So it's going to execute super fast. And we didn't have to do pre-aggregations of everything for this, nor did we have to do everything on the fly. So in that way, star tree lets you choose your balance. It lets you choose your overhead between pre-aggregating everything and doing everything on the fly. This really helps when you have to do complex ad hoc slice and dice, or even when you have to do like point lookups. Another index of particular interest to us is the JSON index. So we saw in the demo that we had a complex person payload, and we could ingest it as it is without any issues. and we applied some UDFs at query time. But then to make our queries faster, we moved those UDFs to ingestion time. And while that worked for us, it's not the best option because that's going to make your ingestion slower. And also every time you want to extract a new field, you have to go to the Pinot schema, add the new column, add some transform functions for that. So that's going to make you lose some flexibility. And also this extraction logic, writing that extraction logic can become very ambiguous if you have like arrays of complex objects in complex objects. So this is where JSON index will help you. With JSON index, an index will be created on each and every field in your complex object. And so when you have to run a query like this, say you want to look at the first address of each person and check if the street is Fun Street. So we did some benchmarking for this query with and without JSON index. Without JSON index, this query took like tens of seconds, but with JSON index, it executed in just a few milliseconds. And that's because with JSON index, this just becomes like an index lookup. So it's like going to be really fast. And indexing really helps you when you have to bring your latencies down by reducing the number of documents that you're scanning. Another optimization that helps is partitioning, that helps you reduce the number of segments that you're querying. And to talk about partitioning, since that is something we really work beautifully with Kafka, I'm going to invite Tim again.
Okay, and you can keep sharing now. I don't
Okay.
need to go back to mine. I talked about this a little bit, but not much, and we just did it with shapes. But here is actual JSON, which is somewhat more concrete. So if member ID, that person object, is being serialized as the value of that Kafka message, and if member ID is also being used as the key, recalling that every message is a key value pair, then you're going to take member ID and run it through the hash function, which I think is murmur3. It doesn't even matter what it is. It's just a hash function, and mod the number of partitions, and then that says what partition we write to. And there's another. There you go. And Pinot is aware of that process, right? This is not a naive integration between the two systems, so it's aware that that topic is being partitioned in a certain way and is creating its segments such that that will be efficient. And the nice thing about that is, so just imagine, there are a number of nice things, but for one, imagine you're doing a bulk load, you're setting things up for the first time. You've got a topic with a lot of data in it. You've got nice sequential reads happening quickly from partitions on brokers, writing into Pinot, since you've got the affinity between Kafka partitions and Pinot segments. And when Pinot is doing query routing on its end, it's able to use partition awareness to its advantage in that process. Tiered storage is another, boy, there's so much that's important about this. If you use event streaming the way like I would ask you to use it, make Kafka your system of record. That doesn't make databases go away, by the way, and let's not have that discussion just yet. Maybe if there's time later, if you want to ask about that, we can. But if fundamentally you build your system around events, Kafka topics are the system of record for those events. You've got Pinot for analytics on the back end. You're going to have various other databases inside the system. There'll be Postgres instances and whatever it is you're into, Mongo. But if topics are the system of record and events live in topics, you're going to get, just for one example, more value out of your analytics if more things are stored in those topics, right? That is to say, if your retention period is longer, once that becomes your system of record, there's this incentive to have a longer retention period. Well, that's expensive if that means you have to stand up a lot of brokers or a lot of storage on the brokers. You could put a lot of storage on a broker, but there's a limit, and that's going to cost money. So tiered storage is a feature that makes longer retention periods economical, right? They're almost always possible, but it just makes them economical by letting you put data past a certain age into, say, cloud blob store of your choice, or under extreme conditions, if you're really into it, locally hosted blob store that implements S3 API or whatever it is, right? Usually it's just S3, but there are, excuse me, 3 ways to skin this cat, 2 of which are operational right now. One is warning, commercial things being discussed in the next 45 seconds. Confluent Cloud offers tiered storage. So you can say, past a certain age, shuffle it off to S3 or Google Blob Store or whatever. And Confluent Platform also adds tiered storage. That's the commercial version of the Confluent product. So if you're running that on-prem, you can, I shouldn't say on-prem, self-managed. You can define a tier for the upper tier of storage there as well. Also in open source Apache Kafka, KIP 405 is an enhancement currently underway. And my guess is that KIP will be merged sometime this year, but that'll be tiered storage in the open source product as well. A few takeaways. I think I've made the case that, or at least talked about how Kafka is good data infrastructure for event stream systems. It really is the de facto standard, and there is a movement, just kind of a large secular trend in software architecture towards event streaming and event-based systems. Kafka finds its way to the center of a lot of those systems. And for many kinds of operationalized queries, Kafka has good analytics solutions in the form of Kafka streams and ksqlDB that can provide good real-time, event at a time answers for queries that you know already. But it doesn't cover everything. Neha.
Yeah, and that's where Pinot steps in. And we saw how Pinot is purpose-built for ultra-low latency analytics, and it can do them at even extremely high throughput. And all the indexing strategies and the pre-aggregation techniques that make Pinot a great solution for user-facing real-time analytics. We saw how Kafka and Pinot work together. We saw a demo of how very easy it is to go from some events in Kafka to analytics in Pinot, making Kafka and Pinot the perfect combination for user-facing real-time analytics. Thanks. That's it from us.
Thank you very much. Thanks for being here, folks. Look at me take some questions.
Yeah, if folks have questions, please post them in the chat here. Seeing lots of good questions coming in and lots of answers being sent back out. So I think pretty much everything that's coming in has been answered so far. But if you have more questions, please do ask them. I will say thank you, Neha and Tim. That was very, very interesting talk. I was doing a little bit of checking out the documentation at the same time, and it looks like you have some great docs in the Pinot project over here. Looks like there's a couple of different languages you can use to interface with it, and looks like you have nice guides for getting started on AWS and Google and Microsoft on the big public cloud. So lots of helpful material there. Getting lots of great thank yous here and great demo, yeah. Awesome. Well, there's a question right there from David. I think Kafka was getting rid of Zookeeper. Will Pinot be doing the same?
No, we will not be doing the same. And I don't think we have thought about that either. So yeah, short answer is no.
Perfect.
Soon enough, though.
Tim, do you have a virtual thing going on in the corner of your screen there? Is that?
What's that?
Am I the one who sees that?
This?
Yeah. Is that real?
Oh, no, that's a light. I converted my desk to standing desk mode while Neha was talking because my back has been hurting. Now you guys know. And that's the light that's normally just kind of hair light.
Cool. That's nice.
Welcome to my studio.
Yeah.
So I'm reading this question, what's the default connection between Pinot and Kafka? And I did not quite follow the question. Would you mind?
It's a connector, right? Neha, isn't there a Pinot connector?
Oh, so if that's what you mean, so yes, there is a connector that ingests from Kafka, and you would pretty much, it's very seamless, or as like I showed in the demo, all you have to do is just provide the Kafka topic and the name of the URL of the broker, and that's it. Sometimes you can give like some more properties like your schema registry or some SSL settings, and that's it.
And
All of
I
the
neglected in my Kafka overview to talk at all about Kafka Connect, which would have been helpful for answering this question. But Connect is a part of Kafka, open source Kafka, part of the ecosystem. It's a server process that you stand up outside of the Kafka cluster proper, the Kafka brokers. You deploy a little piece of connector code that's been built for you, configure it by blasting a little piece of JSON at a REST endpoint, and then it does everything Neha just said at that point. So it's been written for you.
And
Wait, somebody.
regarding does Pinot have built-in ML support currently similar to BigQuery? It does not, but it is used in a lot of applications that are tuned towards queries uh, like ML applications, data science applications. For example, one of the best examples of this is the LinkedIn feed. So every time you go onto your LinkedIn feed, the algorithm that decides what to show you, the freshest content and whether you've interacted with it before and all the recommendations, that engine keeps making a query to Pinot every time it has to show you your feed. So there are certainly possibilities of using Pinot in ML-based applications, but nothing that is uh, directly there. One thing I'd like to mention is that we have an application called Third Eye, which is also part of the Pinot repo currently. And Third Eye is used for anomaly detection and root cause analysis. So if that's something you'd be interested in, I would certainly recommend you go check that out.
Sydney asked, how does one handle schema evolution on the JSON message for processing with ksql and Pinot schemas? I can answer the ksql question. That's actually historically been kind of a pain, Sydney. I mean, schema evolution is always a pain. It's never, nobody has ever made it an exciting thing. But ksql has just recently grown in its syntax a create or replace statement. So when you're creating a query in ksql, you've got a schema change. It's got a convenient way to basically nuke the old one and start up the new one. Now for like zero downtime deploys, and that's I don't want to go on for too long. The ways one does that with a database, the analogies are fairly direct to the way one does that with Kafka, and made somewhat easier by the fact that events are immutable, so you get some simplifying assumptions, but it's doable in ksql. Abdul asked, why is Kafka not written in C++? I'm not sure, but pull requests are open. So no, it maybe would be more efficient. It's just the history of how it was written and where it is. I think the real story that you get there with distributed systems is you can get more predictable like P99 latencies out of non-JVM systems because there's no GC that ever happens. But it's not clear that optimizing single node performance is really where one's money ought to be spent. And that you see that play out in the Cassandra and ksqlDB world, just in the NoSQL world. That's an interesting competition, kind of academically interesting, but Java is where it is and probably where it's going to stay.
So does question from Aditya, Kafka listens to Pinot controller or broker? So Kafka does not listen to any of the Pinot components. It is Pinot that will be listening, or rather talking to the Kafka components. So the Pinot controller is the one who will talk to the Kafka topic and pretty much get just two things: the number of partitions and the offsets for each partition. And from there on, Pinot just manages everything and just goes to Kafka for consuming the data. And a question on the similar topic: what controls the interval at which Pinot consumes data from a Kafka topic? And how does this impact the age of the data that can be made available to a user via a query? So when you create your table, we have the ability to define whether we have the ability to define a offset criteria. So you can say something like earliest offset or latest offset, or if the stream supports it, something more fancy like 5 days ago. So in that way, you can control exactly where from the Kafka topic you want to start consuming. And yeah, so if having all the data available is your concern, you would pretty much just say, start consuming from the earliest offset, and Pinot will just take it from there, consume everything. How are Kafka's partitions and Pinot's segments mapped? So like I showed in the architecture diagram, we had 4 partitions and we created like 4 Kafka consumers across the available servers. So the mapping is 1-to-1. For every partition, we will create a segment on the Pinot cluster. If you have replication set, then we will create several segments consuming from the same partition. And yeah, that's it. So when we are consuming from a partition, if the stream has used some partitioning key, then we know that consuming from this partition is only going to give us data for that specific partitioning key. And that's how we use the Kafka's partitioning information in queries. In case you want to create more UDFs using Java, yes, there is a guide on the documentation that will show you exactly how to do that. There is also a blog written by one of the Pinot committers who contributed that feature on how you can go about doing that. And I can, or if someone from the team is around, if you mind just posting links for both of those, that would be really helpful. Do you have thoughts on multi-tenancy design patterns from Kafka to Pinot? I'm not quite sure what you mean by multi-tenancy patterns from Kafka to Pinot. I believe individually, both Kafka and Pinot have support for multi-tenancy. I can speak from the Pinot side that like you don't need to create a cluster for every use case that you would come up with. Like for example, in the LinkedIn examples that we saw, all like there's about 70 or 80 production use cases that are all served by the single cluster, and they achieve isolation using multi-tenancy at the Pinot level. And Tim, do you have any thoughts to share?
Yes, I do. I'm going to link a podcast. That's a bigger topic when it comes to Kafka, which does not have native multi-tenancy support, but there are things you can do. And here's a link to a podcast I interviewed Kafka core engineer named Anna Povsner, who talks about that. And somebody upstairs just turned my light off. So I'm going to turn that back on. There, sorry, I looked poorly lit for a minute. Anyway, check out that podcast if you're interested. I thought there was another question that looked Kafka shaped. No, okay. No more from me. Oh, have I been? Oh, well, yeah, sorry. I direct messaged that to Apache Pinot. Thanks, Apache Pinot, for actually sharing that thing I tried to send to everybody. How do you even Zoom? I guess I need help.
So does the star tree index in Pinot adapt to existing and new scheduled queries in Pinot and historic user queries? So I'm again not exactly sure what you mean. The star tree index is not dynamic for, I mean, it's going to be the same for a given set of data. So once you have a set of data, like when you're creating the segment, during the segment creation process, the star tree will be created based on the dimensions that you chose that you want to pre-aggregate. All those dimension combinations will be materialized. There's a knob for you to decide that if only X number of rows are remaining in this combination, stop pre-aggregation. And once that is created, that is pretty much fixed with that portion of data. Every time you get new data, you're going to create new star trees for the new segments. And if I misunderstood your question, please feel free to elaborate on the chat. When to choose Pinot over ksqlDB pull queries and vice versa. So I would say that if you have ultra low latency, like milliseconds queries requirement in extremely high throughput loads, and you want to put like a user-facing dashboard, like you want to make it user-facing, you're going to have lots of concurrent users, like think scale of LinkedIn, all of LinkedIn's active members, or think of the scale of Uber Eats restaurant manager, all the restaurant owners across the globe, and you want interactive performance for that. And you want to do ad hoc slice and dice where you have many dimensions and arbitrarily you're going to have to drill down and roll up on different dimensions and not know about it in advance. That's when you would use Pinot.
Yep, and I'd echo that. The way I think about it is if you're doing anything ad hoc, ksqlDB is not an ad hoc query language. It's an application-oriented streaming SQL. And yes, it can perform analytics computations, but there are things that you know about, that you compute in advance, or you decide in advance to compute and make accessible to applications. And it's really good for that. It's an incredibly helpful tool for building applications with Kafka. But if you've got anything in the ad hoc direction, you'll be frustrated.
And having said what I said, Pinot can also be used for more relaxed workloads or lesser query workloads. So if, that's really going to help you. You don't have to it's not a highly specialized database only. You can use it for dashboarding, for your charts, and for ad hoc exploration. So that's going to really help you when you don't have to create different query engines every time you have a different workload. So yeah. Briefly talk about built-in performance tools for Pinot components. Sure. So let's start with the servers. So on the servers, in each segment, we can create a bunch of powerful indexes, like I showed in one of the slides. So inverted indexes, sorted indexes is something that will help you a lot. And then the advanced indexes, like if you have geospatial data, you can use geospatial indexes. If you want to do free text search, you can use a text index. If you have a lot of range queries, you can use range indexes. Then we also looked at the star tree index, JSON index. Some other things is the partitioning. So you can, like Tim explained, partitioning is really going to help you reduce the number of segments that you query. Other than that, we also have really smart segment assignment strategies. For example, we have something called replica groups, which let you control the number of servers that your query spans to. So at every level, we have something with indexing to reduce the number of records, with partitioning to reduce the number of segments, with segment assignment strategies to reduce the number of servers you span to. Some other things worth mentioning is in our real-time ingestion, we try to use off-heap as much as possible. Our segments are memory mapped. So with the off-heap thing, we kind of consciously everywhere have tried to avoid anything that will give us giant GC pauses, which can when you're looking at milliseconds latencies, if you have GC pauses of even half a second, that's really going to hurt you. So we do off heap a lot. And yeah, so this is a very dense topic. So I don't want to just keep rambling on about that. So if it's okay, we can chat offline more about that.
Okay.
Is XML messages ingestion possible with indexing like with JSON? I don't believe so. Right now, we can ingest in Pinot, JSON, Avro, CSV, Parquet, Thrift, ORC, but
Of
we
course,
do not
if
have. Yeah, go ahead.
if you're using Kafka and you've got XML that you ingest into a Kafka topic, it'd be trivial to write a translator from XML to JSON that you could then ingest. It's like once it's in Kafka, you've got options to be able to do those transformations functionally and get it into JSON like respectable data, right? You can even make it YAML if you want. If you just want to watch the world burn, that's your system. You know. Shout out to YAML, David. Have a good evening up north. All right.
Timeline for graduating from incubator status. If so, I don't know. Honestly, sorry. If anyone from the team is here and has any insights on that, please chime in. Yes, Tim does have a fantastic microphone and camera setup.
I did miss that one. It's I'm not gonna lie, it's a pretty good microphone.
Excellent. Maybe we'll just give people maybe 2 more minutes here if they have any final wrap-up kind of questions, and we'll call it an evening or a day, depending on where you are, or morning. It's the Pinot Slack link if anyone wants to sign up for that. And as we've said in the chat here a bit, we will be posting this to YouTube and to the meetup page, the recording here. And yeah, next week,
Yes.
more Pinot meetups, and Tim's got a meetup for Walmart Labs, and Data Science DC, sign up for our meetup group so you find out when the next meetups are happening.
Getting you that link. Here is someone asked for the Confluent Community Slack link. It's right there. Please join. Oh, I just DM'd that to Apache Pinot because I don't think I can do anything else. No, I can. I totally can. There. Sorry. Thank you. Let's put it in there a few more times. At least.
No one will miss it.
No. Thank you, Karine, for doing that for me. Okay.
Yes.
Bye, everybody. Have a good night.
You,
Thanks
Thank
for coming.
Tim. Thank you, Neha.
Thanks for being awesome, Neha.
Come out. Have a great night.
Thank you. Thanks,
Bye.
everyone.
Bye.